Assalamu alaikum everyone. This is Shakil, a level physics teacher, and today I am here with a new video in which I'm going to solve some questions from the topic vectors. And this topic is actually in chapter 1, that is physical quantities and SI units. So the last topic of chapter 1 is vector addition, simple vector addition. So we have to, there is I have already shared the video for the basic points of the vector addition. You can consult that video. Over here, what we have to do is we have to solve some questions. Okay, so let's start with question 1. It's always advised to read the question very carefully. It says that the diagram of the two vectors x and y are shown. X is pointed this way, and this is vector y. And they're saying in which vector triangle does the vector z show the magnitude and direction of vector x minus y. So basically, this is a vector addition case in which the vector z is showing the magnitude of x minus y. So we can say that z equals x minus y. And from here, we can also say that z plus y equal to x. So these can be the two expressions that we have to use. Actually, we have to avoid this negative sign because in addition of vectors, we always add the vector. The negative sign means that your vector would be in opposite direction. Let's say we can rewrite it as z equal x plus minus y. So it means that x and negative y vector are added together. And whenever there's a positive sign, it means both the vectors are arranged in head to tail rule. So y is pointing to your right. So if you see, is there in any of the diagram, is there anywhere that negative y is there? So in A, no, it is y. In B, it is y still. In C, it is y. And in D, it is still y. So in neither of the options, negative y is used. So we cannot use this option. Now we have to try for this z plus y. So look in the diagram in which z and y are arranged in head to tail rule. So look in the diagram 1. So if you look in the diagram 1, we'll say that this is z and this is y. So both are not arranged in head to tail rule. Okay, this is not the option. Let's go to B. Z and y both are arranged in head to tail rule. And the third vector will be their resultant then. So we can say that x equals z plus y. So yes, that is our option B. Okay, let's move forward to question number 2. Question number 2 says that two forces, each of 10 Newton, act at a point P as shown in the diagram. The angle between the direction of the force is 120. So two forces of 10 Newton are there with the angle of 120 degree between them. What is the magnitude of resultant force? So we have to find resultant force. So what we will do over here is, it is a special case in which, like, one thing is you need to remember, if two forces of equal magnitude with angle of 120 degrees given, then the resultant will have the same magnitude as that of vectors, So 10 Newton. So through our direct knowledge, the answer is 10 Newton. But we can also prove it by head to tail rule. So first take the vector. First draw this vector of 10 Newton. So I'm drawing this vector of 10 Newton. Okay, then draw the other vector, which is like this one, this 10 Newton. So now you have to draw that one. And according to head to tail rule, we cannot change the direction, but we can change the position. So this is 10 Newton. Now the angle between them was 120, but actually this angle was 120. If you look in the diagram, it is similar, this angle. So the interior angle between them will be 60 degree now. And as you have to find the resultant, so actually this would be the resultant. So now what you'll be doing is, you know the two sides, like 10 Newton, and angle between them is also known. So you will be using cosine rule. So you will be using cosine rule here to get the answer. And that is r square equal 10 square plus 10 square minus 2 into first vector into second vector into angle between them. And then you will take square root of it and it will be cancelling away. And your answer is going to be 10 Newton. Okay, move on to question number 3. This question is related to components. So the diagram shows resultant force and its horizontal and vertical components. So this is resultant, this is horizontal component, and this is vertical component, and theta is the angle of resultant with horizontal component. They said that horizontal component is 20 Newton and angle is 30 degree. What is the vertical component? So what you will do is, you will say that, look, the horizontal component is given. So you know the horizontal component value is f cos theta, because adjacent to angle is f cos theta, and the vertical component is f sine theta. So you have already the value of horizontal component. So we say horizontal component fx is f cos theta. So horizontal component is 20, f you don't know, and angle is 30. So doing this, 20 over cos 30, this will give you the answer of f. Once you found f, you can easily find vertical component, because it is like this. Fy is f sine theta. So f you have already calculated. It is like 20 over cos 30 and into sine 30, because we keep the angle same for both the components. For both the components, angle is always same. And then what you will do is you will find its value. You will calculate its value, and its value is going to be, okay, let me calculate the value quickly. It is 20 divided by cos 0.939 and multiplied by 0.5. So that is 10.64. Okay, so that is the value, 10.64. But hold on, I'm using the laptop calculator, so I guess it's not giving me the correct answer. So let me do it again. Oh yeah, sorry, it is 11.54. So 11.54, so it means C is the option. Okay, moving forward to next question, which is again related to resolution. A vector quantity V is resolved into two perpendicular components x and y. The angle between V and component of x is theta. Like the angle for V is theta, x and y are the components of V. So the angle between the component x and v is increased from 0 to 90 degree. How do the magnitude of x and y changes as theta is changing? So the thing is, you know, this x is equal to v cos theta, and this y is equal to v sine theta. So when theta is increased from 0 to 90 degree, so let's see if it is 0, what should be the answer? V cos 0. So it is v, because cos 0 is 1. And if it is 90, if the angle is 90, then cos 90 is 0. So 0 into v is 0. It means that as the angle increases, as the theta angle increases, v cos theta, which is actually x, it is going to decrease. So x is going to decrease. Okay, now let's talk about y. Y is sine theta. So if you put sine 0, because the angle is increased from 0 to 90, so sine 0 is 0. And if you put 90, so sine 90 is 1. So it means that when the angle is increasing, then the value of y is also increasing. So it means this C is your answer. Okay, let's move on to question number 5, which is mentioned as a challenging question over here. So how we will do this? A pendulum bob is held stationary by horizontal force H. The two forces acting on the bob are shown in the diagram. So this is the pendulum bob. One is the horizontal force H, which you are applying to pull it to right side. W is the weight of pendulum, as T is the tension in the rope, which is always towards the fixed end. And 30 degree is the angle which T is making with vertical line. So the tension in the string is T, the weight is W. Which statement is correct? So actually what we have to do is, we have to resolve this t. So let's just resolve this t. So I am drawing a vertical line over here, and if this angle is 30, then this angle should also be 30. Now I'm going to resolve t. So you know that adjacent to angle is always cos. So this is t cos 30. And then the next component is always sine. So this is t sine 30. Now, as it is stationary, so forces to right is equal to forces to left, and forces downward equal forces upward because it is at rest. So it means we can say that H is equal to T sine 30, like the left force equal right force, and then W, which is downward force, is equal to upward force. So now you have to look which option is correct. So C option seems to be correct because this is what we have done over there. W equal T cos 30. Question number 6. It's again, question number 6 is similar to question number 3. These are similar. Question number 3 and 6 are similar. So what you have to do is 5 Newton is the resultant force, 3 Newton is Y, and you have to find value of X, right? And over here, okay, the angle is not given. Yeah, the angle is not given. So you have to find value of OX. Okay, so we will adopt a different method. We will first draw X, then we will draw Y, and then we will draw the resultant. So resultant is 5, Y is 3. These are right angle, and you have to find X. So over here, you can use Pythagoras theorem. So using Pythagoras theorem, hypotenuse square equal base square plus perpendicular square. So it is hypotenuse is 5, base is X, and perpendicular is 3. So when you will solve it, the answer is X square equal 25 minus 9. It is 16. Take its square root. So your answer is 4. So this is 4 Newton. So I've done it in a different way. Question number 7. Question number 7 is very simple. 5 kilometer is the vector and 53-degree angle. So you have to find the displacement along XY, this one. So you resolve 5. So this is 5 cos 53, right? 5 cos 53, and you will get the answer. And the answer will be 4 kilometer over here. Okay, let's move to question number 8 now. Again, a very simple question. 3 Newton, 5 Newton are acting at right angle to each other. What is the net force? So like this is 3 Newton, head to tail rule. This is 5 Newton, and you have to find the net force. So use Pythagoras theorem over here, which is like F equal 3 square plus 5 square whole square root. So that will give you the answer of 34 square root, and that will be 5.8. Question number 9 is related to, I have to write it again, Pythagoras theorem, and then F is 5 square plus 3 square, and that's how you will get the answer of C, which is 5.8. Okay, question number 9 is again vector addition. P and Q are the vectors, and they're saying that which vector best represents the resultant displacement P minus Q. P minus Q, so it is actually P minus Q, but we'll do P plus minus Q. And minus Q is what? It is a negative vector of Q. And negative vector of Q will be in opposite direction, same length, but in opposite direction. So we'll say that, okay, this is vector P, and negative Q will be like this, head to tail rule, and this will be the resultant. So obviously, D is looking similar to the resultant. Question number 10. Question number 10, 3 forces are acting at a point P, and you have to find the resultant. So first, whenever 3 or 4 forces are given, you have to find resultant of first 2 forces, which are easier to do. Like these are at right angles, so just solve them. Just for the moment, ignore this vector. So only 2 vectors are there, 4 and 3. So when you solve it, 4 and 3, so you will get a resultant of 5 by Pythagoras theorem. So it means that the resultant of these two is 5 Newton this way. Now, let's talk about the other one, which is also there, like this one. So 5 and 4 both are opposite to each other. So obviously the resultant will be 1 Newton towards 5. So that is D. Okay, moving on to question number 11 now. Question number 11 is again like P and Q are the two vectors, and which diagram best represents P minus Q. Again, P minus Q means P plus minus Q. And you know, minus Q means the negative vector, which is a vector equal in magnitude to Q, but opposite in direction, right? Okay, so now we have to look for P plus minus Q. So let's make a head to tail rule diagram. So P is this way and negative Q is this way. And obviously the resultant is going to be this, which looks similar to C. Okay, question number 12 is very simple. Two vectors P and Q are added and R is the resultant. Which quantity represented by P and Q? So obviously P and Q should be vectors, right? So kinetic energy, no, it is a scalar. Power, it is a scalar. Speed, it is a scalar. Velocity, yes, it is a vector. So D is your answer because you can only plot vectors. Okay, question number 13. Question number 13 is, okay, question number 13 is, okay. Question number 13 says that three forces are acting. Up thrust is 10,000 on the balloon, 9,000 is its weight, and 500 is the sideways force. So they're saying, what is the vertical component of resultant force on the balloon? Vertical component. Vertical means like this. So we say that the weight is 9,000 over here, up thrust is 1,000. So when you simplify it, these two, like 10,000 is upward and 9,000 is downward. So it means the force would be resultant vertical force will be 1,000 Newton upward. So it is 1,000. So no need to treat this sideways because we have to find the vertical component. So the emphasis is on vertical component. So that's why we only deal these two. So we find resultant of these two, which is 1,000. So that's why 1,000 is our answer. Let's move to question number 14. That is quite simple. Two forces of magnitude 8 Newton acting on the object. The angle is 60 degree. What is the magnitude of resultant force? Okay, the angle is 60 degree between them. So we will say that if like this is 8 Newton and this is 8 Newton and 60 degree is the angle. So we arrange them according to head to tail rule, like 8 and this is the 8. And let's say this angle was 60 degrees. So the interior angle will be 120 degree. So now what we will do is, actually, whenever we have to find resultant, we have to arrange the vectors in head to tail rule. So we will draw the first vector and then we will draw the second such that the tail of second is meeting the head of first and we can't change their direction. We have to keep the direction same. So this is the resultant which we have to find. So you have two sides and an angle between them. So like 8 and angle between them is 120. So you will use cosine rule over here. I hope you can use it yourself. So you can easily use cosine rule over here. Okay, so you have to use cosine rule. So which is like resultant is 8 square plus 8 square minus 2 into 8 into 8 into cos 120. Taking square root will give you the answer. Next, a 10 Newton force is resolved into two components, right angle components. One component is 8. What is the other component? So this question is similar to the previous two questions that we have already done. So you can do it yourself. Try it yourself, right? Pause the video and try this question yourself. This question is exactly similar to question number 6 and question number 3. So this is similar to question number 6 and question number 3. So question 3 and 6. Okay, so I hope you're done and you have got the right answer. Okay, let's move forward to question number 16. Question number 16 has got two parts. Like again, it is very easy, 7 and 5. So what you have to do is you have to use Pythagoras theorem over here. So the resultant will be 7 square plus 5 square and square root. Over here, one of the force is missing and this force is 20 Newton. So what you will do is you will first find the resultant of the vertical forces, and then you will find the resultant of these horizontal forces. So the vertical forces resultant is 20 Newton upward and the horizontal one is 60 Newton this. And then again, you will use Pythagoras theorem on this to find the answer. Question number 17, very simple. You have to look for the perpendicular components. So of course, adjacent to angle is cos. So this is 10 cos 45. And the other right angle component is sine. So 10 sine 45. Over here again, adjacent to angle is cos. So 85 cos 20. And this would be 85 sine 20. Moving forward, question number 18. Question number 18, there's a vector shown which diagram does not represent R as two perpendicular component. So you can fit that vector over here. You can fit that vector over here. Don't change the direction. And that vector is similar to this, and you can fit that vector over here. So all the three diagrams are correct, but over here, the vector is also fitting on another vector. So this cannot be true. So C is your answer. 19 is a bit different question. Three forces are acting and you have to find resultant for them, and what you have to do is you have to arrange them according to head to tail rule. So these are like your vectors like 1, 2 and 3. So first draw vector 1, then draw second vector such that its tail is coinciding with first, then draw third such that its tail is coinciding with the head of second. Don't draw and as it is short in length, so you have to draw almost the same length. And then resultant, you know, resultant starts from first vector and it points at the last one. So if you see, the diagram is similar to B over here. Okay, this question 20, we have done two questions similar to this before. Again, it is X is Y minus Z. So which diagram best represents the vector Z? So Z will be resultant then. So you can say that Z equals Y minus X. Minus X, because Z is the resultant. Okay, because they're saying which diagram best represents Z. So Y minus X means Y plus minus X. So minus X is a negative vector of X, opposite in direction. So we will draw Y and then we will draw negative X. And then we will draw the resultant. Resultant always starts from tail of first and its head points at head of the last. So this is the resultant. So obviously it looks similar to A. Question number 22. An aeroplane can fly at velocity x with the moving in still air. When flying in a wind, aeroplane's velocity relative to ground is y. Of course, when still air is there, its velocity is x. And when a wind will there, then its direction is going to be changed. As its direction is changed, so we say its velocity will also change. So that is y relative to ground. So which vector diagram shows the magnitude and direction of the wind velocity W? So you know X and W, these two are the action vectors, and Y is the resultant vector, because X is the velocity of the aeroplane when in still air, W is the wind which is acting on the still air on the aeroplane. And then of course it will change the velocity into y. So y is the resultant. So we have to see that actually it will be y equal x plus w, because x and w both are action vectors. So these two should be arranged in head to tail rule. Head to tail rule. Now look in the diagram in which x and w are arranged in head to tail rule. So x and w, head to tail rule. Okay, and over here in the second diagram, X and W are not arranged in head to tail rule. They are tail and tail. In C, X and W are again not arranged in head to tail rule, tail and tail. And in D, X and W are again not arranged in head to tail rule. It means that our answer is A then. Because in A, X and Y, W are arranged in head to tail rule and Y is their resultant. Okay, now we have to go to the other part of the sheet, which is the theoretic questions. You have to state the difference between a scalar quantity and a vector quantity. So obviously we know that a scalar is represented by a magnitude unit and vector is defined by a magnitude unit and direction. A direction is also required, so that's the basic difference. So next question is two forces of 6 Newton and 8 Newton acts at point P. Both forces are making an angle of 40 degree. So you have to find its resultant. So you have to find the resultant. Okay. So the one force is, let's say, over here, which is 8 Newton. Other force is over here. They have already drawn the angle accurately, like 40 degrees. So this is 60. So what you should be doing is, they're saying draw a vector diagram. So it means that you have to draw it and you will say that, let's say 2 Newton equal to 1 centimeter. So this would like make 8 Newton as 4 centimeter and 6 Newton as 3 centimeter. So now you will take a scale and you will actually draw this line as 4 centimeter and you will draw this line as 3 centimeter. And then again, putting scale over here, you will draw a line of 4 centimeter because these are parallel. And the last, this line should be 3 centimeter. And you know the resultant is always from the origin for the parallelogram. This is your resultant. So what you will do is you will measure its length with ruler. And after measuring its length with ruler, you will convert that into Newton. So length into scale value, which is 2 Newton, that will give you the value of resultant. So the resultant is length into 2 Newton, whatever the length is coming. Okay. The next question 2 is very simple. Again, you have to distinguish between scalar and vector. So of course, direction is the distinguishing factor. You have to underline all the scalar quantities. So kinetic energy is scalar, mass is scalar, power is scalar, and rest of the three quantities are vectors. Okay, next question, which is a stone of weight 5 Newton. This is the stone of weight. This is stone and its weight is vertically downward. When the string makes an angle of 35 degree to the vertical, so there is a string with a tension of 6.1 Newton acting at 35 degree with the line of action of weight. Like this is known as line of action of weight. This dotted line is line of action of weight. Okay, so what you have to do over here is you have to determine the resultant force that acts on the stone. So for this, you will be using, what you will be using is triangle method. So what you have to do is you have to make a triangle of the two forces like 5 Newton and 6.1 Newton, and of course following head to tail rule. Head to tail rule. Okay, so we will say that 5 Newton is downward and 6.1 Newton is this way with making an angle of 35 degree. It means that the resultant will be this one. Resultant always start from tail of first and it points at head of last. So this is resultant. As you know that you have like two sides and an angle between them, it means you will be using cosine rule. Whenever two sides and angle between them is given, you will be using cosine rule to find the resultant. So the cosine rule will be like resultant square equals 6.1 square plus 5 square minus 2 into 6.1 into 5 into cos of angle between them. And obviously you'll be taking square root to find the value of r. So that's how you can find its value. About the direction, what you will be doing is, for direction, of course, you have to find the angle. The angle, the tension, the resultant is making with 5 Newton. So for direction, usually it's the angle. Direction means angle which resultant is making with any side. Okay, so I have chosen the vertical side of 5 Newton, like this side. Okay, so now for angle, we know that we have all the three sides and we have one angle, already angle 35, so we can use sine rule. So for direction, you will be using sine rule. Sine rule says A over sine A equals B over sine B, right? So over here, we know 35, so it means resultant is over A side, let's say this is A. And let's say 6.1 is B and this is C. So I'll be writing like resultant value that is coming from the above calculation, this one, divided by sine of 35 equal B. So B is like 6.1 over angle, because this is the angle that you have to find. So after calculating this, you can find the value of theta, right? So the theta will be 6.1 over your resultant value into sine 35, and then you will take sine inverse. So you'll simply put it in the calculator, right? Put it in the, and you know the sine inverse is basically when you press shift button on the calculator, after that you press sine, so it will be like sine inverse, and then you will be putting all the values over there. Okay, the next question is again very simple. It's like only about the components of 7.5 at 40-degree angle. So we know adjacent to angle is cos. So it is 7.5 cos 40. And the vertical component is always sine, 7.5 sine 40. So this is like 7.5 cos 40. You'll solve it to write the answer in two significant figure. And over here it is 7.5 sine 40. And again, you will write answer in two significant figure because 7.5 is having two significant figure. Okay. Question number 5 is an object which is balanced by two chords, chord A and chord B. So you know its weight is acting downward and tension in the rope is always acting away from the weight, away from the applied. So we are done the first part, drawing the arrows to represent the direction of the forces acting on the object. So weight is downward, rope B towards your right, and tension in rope A is upwards. Okay, the next thing is you have to find the angle theta. You have to find this angle theta. So this angle. So TB is this, TA is this, weight is downward, and what else is given? Tension in rope A is given, which is 69, and then the mass is given, so you can find object's weight as well. So object's weight will be 48.06. So this force is 48.06 Newton. And this force is how much? 69. This is 69 Newton. Okay. So now we have to draw the vector triangle. So vector triangle will give us the value of theta. So we will first draw W, which is 48.06. Then we will draw this TA, which is 69. And then we will draw this TB, which is perfectly horizontal. So it means they are at right angle to each other. And the theta angle was of TA with horizontal. So over here, TA with horizontal is this. So you have to find this angle. It's very simple now. This is a right angle triangle. You have two sides. And of course, you know, this side is base. This is perpendicular and this is hypotenuse. So you know base and hypotenuse. So you will be using cos theta over here. So you'll be using cos theta. So cos theta equal base, which is, but the thing is you have to find angle, sorry. So the thing is you don't know TB, but we know perpendicular and hypotenuse. So we'll be using sine theta instead. Sine theta is perpendicular over hypotenuse. So theta is sine inverse 48.06 over 69, and you can solve this. So I hope this worksheet was helpful for you. Thank you so much.